Hey everyone, welcome to another tutorial. This time it is the UserDistanceValueDriver. I saw this in the ideas section about someone trying to control a mirror being on based on the distance from the mirror itself. A good example of this that exists, although I won't show you because I'll have to load into that world, is if you go to the Neos hub, the space station, there's a mirror where if you approach, it'll slowly turn on and then it'll slowly turn off. That's a more advanced use case of this user distance driver. We're going to use it here just to turn this mirror on and off. This is my mirror from the value user override video, but this should work on any mirror or any installation where you want to turn something on or off based on the distance away from things. This could be good for sort of power-ups or particles or even sort of AI maybe, only do stuff when someone is close by. Let's go ahead and inspect my mirror. That's the frame, so we'll go up to mirror here, and we need to go turn off the values override, which I think is on the actual button. We need to turn that one off, and then we've just got our touch toggle back for everyone. This is now back to a global mirror. What we want to do here is we want to change it up, and I'll do this on the local mirror so that there's a room, and then we're not doing the button. We actually don't need the button for this case, so I'm just going to go ahead and delete that. So on the local mirror here, we just need to add one component, and so attach component, transform drivers, and then scroll to the bottom, you'll see user distance value driver T. Select that, and then go for bool. So here's bool, again for boolean. You'll see node here. This is which part of the body must be close before it interacts. So I'm going to set this to be head. Because it's a mirror, it makes sense, but you might want to use feet for, I don't know, like trapdoors or things. You could do that quite easily. And then here, distance is the distance. You need to make sure that you factor in the distance based on where the mirror is parented to. If you have a world which is really big and you parent a mirror to it, that'll make the mirror kind of small in relation to it. So just double check this. You'll have to play around with this a lot. So here we need to set a target field, so I'm going to go ahead and open up a second inspector for the mirror over here. And then I grab the active property and I put this into the target field. So that now means that that's being driven. And then here I say that the far value, this is the value where I'm far away, is off, and the near value, as in when I'm close, is on. And now I need to set this to be a certain distance. So I'm just going to experiment. We'll try 0.5 for now. And then I'm going to move this to the side, and I'm going to go put this near the ground and go to walk run. Bring this down with me here. And then we're going to enable the position mode here. So when I get apparently really, really close to it, it turns on. So you see now it's turning on here. So I need to adjust that distance a bit. So let's grab my inspector from over here and say maybe 1.5, and then we'll try that one out. I'm also going to put this here, parent that one as well. So now we can see, is this turning on or is it need distance? There we go. So you can see here, off, on. I'm going to make that just a little bit further, so 2. And now you see it's on, I go away and it's off. On, off. On, off. That's all there is to it. That is the user distance value driver. Try out with different data types. I believe the way it works in the mirror in the Neos hub is that it uses some form of asset multiplexer or fade operation to fade between the two materials, and it does it using kind of like a relative distance. I think that works with this too. Let's try this out. I don't actually know if this is going to work. I've only ever used this for mirrors, so I'm going to try this out so you get to watch me do it live. So I'm going to go ahead and create let's do a sphere. So what I'm going to do here is a sphere that gets bigger the closer you get to it. Don't need these anymore. So a sphere's size is basically its radius here, so 0.5. So here if we add transform drivers, user distance value driver, float. Let's float. There's float. Then we say the radius of the sphere is what we need to do here. So radius. We're going to say head here again, and then we're going to say that the near value is going to be 10, and the far value is going to be 1. And then the distance, we're going to change that to be kind of 1.5 again. And it's just springing between the two. Interesting. Yeah, I'm not sure how the mirror works, but you see here again where we're doing it on a float. You might want to smooth lerp this. Let me show you how I'd do that. I would say attach component. I haven't done a tutorial on these, but for now just follow along. Data value field float. I would change the target so that it's the value of the float here. And then I'd pull out the logics tooltip. And I would grab the sphere mesh here. And then I would also grab the value field here. So here we've got what the distance value is saying. So away and then close, it goes from 1 to 10. And so now we can plug that into a smooth lerp operation. So operators, no, it's in math. Smooth lerp. So we take this value and then a speed, which we'll set to, I don't know, 1.2. I don't know, that was totally random. There we go. So now as I get closer, it smooth lerps in and out with size. There you go. That's user distance value driver. That's a mouthful. Looks like my distance is a little flaky here, because you can see I can kind of tweak it by just raising my head a little bit. So I might want to edit the distance there or play around with that, but that's for another time. You can also move this around because it's grabbable. That's it. See you next time.